Okay, so this lesson is the first lesson on exponent rules. It says apply using products. What are products? It's the answer to multiplication. Very good. So we're going to be dealing with lots of multiplication today. And the rule for multiplying powers that have the same base, you add the exponent. So let's just talk about what a power and what a base and stuff like that is. Okay? Y'all know what a base is when you're talking about exponents? Okay? The base is the big number on the bottom. Triple B, the big number on the bottom is the base. Okay? The big number on the bottom is the base. The little superscript at the top is called the exponent. And together they make a power. Okay? So this is 2 to the third power. That's a power. 2 to the fifth power. The whole thing is a power. Does that make sense? 2 is the base, 3 is the exponent, 2 is the base, 5 is the exponent. So if they have the same base, we can add the exponents. So if they multiply two things that have the same base, we add the exponents. So that very first example at the top, I have it in purple, I think. It says 2 to the third power times 2 to the fifth power. They both have a base of 2. So your answer will also have a base of 2. And then you add the exponents. 3 plus 5 equals what? 8. So keep the base, add the exponent. Since that's not a huge number, if you want to raise a number to an exponent and you have a graphing calculator or one of my graphing calculators over there, there is a button above the division key that makes a point. I call it the rooftop button. Okay? Y'all see that rooftop button over there above the division key? So you would type in 2 rooftop 8 and hit enter. And what are we getting for 2 to the 8th power? 256. So if it wants you to evaluate the numbers, then that's how you would do it in your calculator. Now, obviously, if we have a variable, we can't do that because we can't put that in the calculator and get a number. So we're going to see some of those as well. So look at problem A. So if they have the same base, what are we going to do the exponents if they're multiplied? Add. So if they multiply, we add. If they have the same base. So a to the second times a to the third power. Keep the base. It's a. And what power am I going to have? 5. 2 plus 3 is 5. So a squared times a cubed is a to the fifth power. Any questions? Okay, look at B. It says 9 times 9 to the 8 times 9 squared. Do they all have the same base? Yeah, so my answer is going to have a base of 9 as well. And then you add all your exponents. Do all of them have an exponent? Yes. That first one, I don't see an exponent, though. What's understood to be my exponent if I don't see one? 1. Very good. So you add 1 plus 8 plus 2, and what do you get? 11. So it's 9 to the 11th power. Any questions so far? All right, on C, they use parentheses because they have a negative number. It really is important whether or not the negative is on the inside or the outside of the parentheses, okay? So when we write our base, we need to keep it in parentheses as well. So this is going to be negative 3 what power? Understand why it's a 7? Because the first one is a first power. Well, problem D, those are all B's. B times B cubed times B to the fifth times B squared. So what do you think the answer is going to be? Which one is it? It is B11. And we don't say B11. We say B to the 11th power. Because if you say variable and the number all together right there, then that's the same thing as saying 11B. And that's not 11B, it's B to the 11th power. Okay? So we don't just say B2, B3, B16. Okay? We say B to the whatever power. Got it? It's important that we speak mathematically correct. Okay. Next rule we're going to learn today is how to take a power of a power. A power of a power. Now, a power of a power is when we have something that already has an exponent on it, and then we raise it to another exponent. So power of a power, something already has an exponent, and then we're raising it to another exponent. And so this says to take the power of a power, you multiply the exponents. So if we have something that already has an exponent, then we raise it to another power, we multiply the two powers. So if they multiply, we add the exponents if they have the same base. And if we take a power of a power, we multiply. Multiply, you add. Power of power, you multiply. So this is pretty simple. A squared to the third. What do you think that's going to be? A to the sixth power. That's it. You just multiply the two exponents. The next one says x squared to the fourth. And y'all, you're going to know when you have power of a power because you're going to see parentheses. Okay. X to the eighth. Very good. Now the next one uses brackets. Why do you think they use brackets? Right, because they're trying to keep the base negative, so they use parentheses there. And so the next far out thing is brackets. So that's just what those are. They're just extra parentheses. So this one's going to be the base is still negative 2. And then 2 times 3 is what? 6 to the 10th power. All right, H looks a little complicated because it's got what we call a binomial in the parentheses, y plus 2. So you just leave the base alone, y plus 2. And then you multiply 6 times 2 and you get what? 12. So just leave the parentheses alone and just do your exponents. Any questions? Alrighty. And then they start throwing everything together at us. Mixing power of powers with multiplying and all this stuff. Okay, if you have more than one thing in the parentheses with an exponent on the outside, everything in the inside gets that exponent. Okay? So this one right here, it says 24 times 13 to the 6th power. Everything is going to get the 6th power. Y'all with me? So 24 is going to get the 6th power, and then 13 is going to get the 6th power. Let me see if these numbers are big. Oh, yeah, these numbers are really big and like over 1 million big. So I'm going to just leave that one alone. Okay? But that just to show you whatever's in parentheses, they each get the power. And if it already has a power, you multiply the one you got with the what it is. So look at J. 9xy, all of it is squared. 9xy, everything is squared. So that means every term inside gets the square. Now the most common mistake, y'all, is people not squaring the number in front. So this is going to be 9 squared times x squared times y squared. Do we know what 9 squared is, y'all? 81. Go ahead and simplify one like that. For sure. And I forgot my one. 81 x squared y squared. Everything on the inside gets the outside exponent. So, how do y'all think we're going to do K? Okay, so negative 4 squared times m squared. What is negative 4 squared? My calculator says negative 16. Which one's right? Is it 16 or negative 16? Right. Say it again. That's right. Because a negative squared means negative times a negative, right? Your calculator lies, and it will tell you that that is a negative 16. So that's why we got to know. If we square a negative, it becomes positive 16. This is 16. Anyway, 16. If you use parentheses, it will. I'm trying it. Yeah. If you use parentheses, it'll do it. Here's what it's doing. Y'all are honors. I can tell you this. What your calculator does is order of operation. So if you just straight up type in negative 4 squared, what your calculator does is make this negative 1 times 4 squared, which is negative 1 times 16, which is negative 16. Does that make sense? That's what your calculator does. Your calculator's default way of solving things is to do order of operation. Uh-huh. I know, that's what I said. Yeah, if you type it in with the parentheses, I believe the parentheses are over the 7 and the 8 key, then it should work. And did you know there's a square key on the calculator? So you don't have to do rooftop to do a square. It's like diagonal from the 7. It says x squared. Now I you just square there without having to do the rooftop. All right, so that y'all just need to know a negative square will be a positive. Now L looks completely different, doesn't it? Okay? L, the negative is on the outside of the parentheses. That changes the ball game. Okay? So that negative on the outside of the parentheses means negative 1 times the inside. So this will be a negative 1 times 5 squared times x squared. And then we square the 5 and get 25. And negative 1 times 25 is negative 25. So do you see the difference? If the negative's on the inside and you square it, it comes out positive. If the negative's on the outside and you square it, it'll be a negative. Does that make sense? Because it's negative 1 times that. And that's what your calculator does it like. So that's why we got to use, that's why where the negative is, inside or the outside of the parentheses, is important. Does that make sense? I square the negative on the inside, it comes out positive. If the negative's on the outside, I square the number and then multiply it times negative 1. Does that make sense? I know it's a little confusing. All right, look at M. These problems are getting a little bit more fun as we go. All right, you see those parentheses? That means we're going to have to do some power of a power. So everything on the inside gets the square. So that means the 2 gets the square, and the x is going to get the square. But the x already has a cube, so what do I do there? It's power of a power, so we multiply them. So that's going to be 2 squared x to the 6 power, and then fix 2 squared. What is 2 squared? So 4x to the 6. So if it's in the parentheses, if it doesn't have an exponent, you give it the exponent. If it does have an exponent, you multiply them. If you want to think about it, this is also 2 to the first, right? Right? And if I multiply the powers, I still get 2 squared on them. So if you think about it that way, it's the same thing. Look at N. Part of it is in parentheses, part of it is not. Y'all see that? So the part of it that's in parentheses, everything is going to get a cube. This D is not going to get a cube because it's not in the parentheses. Y'all with me? So that's going to be 3 to what power? Third. D to what power? 15. And then I'm going to multiply that times that extra D out there on the outside. Do y'all know what 3 to the third power is? 27. Very good. And then what about those D's? They're the same base, aren't they? And they're multiplied, so I do what? I add them, and that's the first, so that's d to the 16th. You understand that? So if you have an extra variable and they're the same base with the other ones, you combine them, you add them. If they're multiplied, you add. Okay, y'all are doing great. We don't like much, promise. All right, so this next one looks exactly the same, pretty much. So what do we do first on problem O, do you reckon? Okay, give everything on the inside of the parentheses the third power. Take care of our powers of powers. So it's going to be 4 to the what? Times x to the 6, and then times x to the 4. Could y'all please tell me what 4 to the third power is? It'd be 16 times 4, wouldn't it? 64. And what about those x's? You add them because they're multiplied and you get x to the 10th. Any questions? Okay, P is similar, but a little bit more involved, I guess you would say. I ain't going to say difficult because it's really not. First of all, there's no parentheses around that 6m squared. So I'm just going to copy that for right now. I'm going to actually separate it with a multiplication dot just to separate my number and my variable. And then what do I do with the parentheses? Yeah, everything gets the fourth power. So it's going to be 2 to the 4th times m to the what? 20th. Now, when I have different numbers and variables and stuff like this going on, I like to rearrange and put my common things together. So I'm going to put my numbers together and then my m's together. So I'm just rearranging. Then I want to evaluate my number. What is 2 to the 4th power? 2 times itself 4 times. 16. So for my numbers, I have 6 times 16. Can somebody tell me what 6 times 16 is? 96. And what do we do with our m's? You add them and get m to the what? 22nd. Any questions? All right. I want you guys to try this one. Check it with somebody when you're done, please. Okay, so 3x to the third is not in parentheses, is it? So I'm just going to copy it. And then you got powers going on in the parentheses, so you're going to get 4 to what power? And x to what power? They already have a power, so you multiply. And I'm going to rearrange because I like my common things to be together. What's 4 to the third power? What's 3 times 64? And what do you do with your x's? And get x to the what? Raise your hand if you got 192 times x to the 12th. Are there any questions? Well, that is the end of section 8.1.